Yes. Okay, so hello everyone. Thanks for joining the third meeting of the APL users group in Barcelona, called APL in Barcelona. And I'm Michail Liarmakopoulos. And this in this meeting we will discuss an old paper. I like to call these meetups historical APL paper reading sessions. It's a paper from 1972. Oh, I didn't parse them correctly here. Okay. So the title. Oh, someone's joined. Okay. Let's accept. Hello, Khalid. We just started. Thanks for joining. So welcome again in the third meetup of APL in Barcelona. Feel free to interrupt if you have any questions or. Hi. Hello. Hi. Yes, we can hear you. Okay. So this meetup, it's about a paper called vsApl Epidemic, or a study of its growth through an extended bibliography. And it was from 1972 on an APL conference of that year by J.C. Rault and G. Demars. And I will do just a small introduction on this kind of sessions. So, okay, admit. So in these sessions, well, this meeting, the contents are: first, I will discuss the structure and the goal of the historical APL paper reading meetings, and then we'll discuss the paper, which unfortunately the Markdown didn't parse correctly the chapters, so it has some chapters. We will see them in as follows, and we will go through the paper. I have it's a small paper, four pages, and the rest of it, I think, it's like it has an appendix with all the papers they used to gather data. So it's a bibliometrics research, and so I copied the discussion they first do in that paper, and then we will go through it, and then we can perhaps discuss it. And you know, I'm pretty sure some questions might pop up in your minds as they did in mine. So about this meetup, how I have thought about it, you're welcome to, to propose anything that it will make it better. We can discuss that as well. You can always email me for any suggestions, because this is a very new meetup. So I'm always open for suggestions or for any help, as I have recently posted a message that I will be needing some help for the next meetup for the end of this month. And if I'll have to prepare it on my own, I'm not sure if it will be at the end of this month, maybe next month, most likely. So the structure of this paper reading meetups, I will decide a paper that I find interesting. Maybe at some point I could do a poll, and you could vote, let's say, out of 3 papers, and we could review any paper you find interesting as well. I think this would be a better way deciding which paper. And then I'll be sending the paper to the group, so you can have a look before the meetup, and then we can go through it and discuss the meetup. There are many papers in the J software group, which are free. They're free of access. For example, if you press, they have pretty much typesetted the papers on the website of JSoftware, which is very practical and very useful. So we don't have to download it from ACM by any unofficial methods, let's say. And the goal of this kind of meetings of the group would be to study actually these languages, APL and J mostly, because I think from there, all the other languages originate from. And then by deeply understanding how they were designed, how they worked, and all the ideas that made them how they are today, will make us better APL JK programmers. So yes, I believe that by understanding the history and the evolution of the ideas, in the end we'll be better programmers in the IRA programming and paradigm. So let me, if I place, let me do the full screen. So this paper is called vsApl an Epidemic, and it's a study of its growth using an extended bibliography. So the authors, I think I have here the paper as well. So the authors have selected a bibliography of from 66, I see, from the 60s, let's say, until 1972 when the paper was written. And they used 340 papers as the data points, pretty much, of the graphs that we'll see in a few. So the first chapter is the summary of the paper, and they say that it's an attempt to demonstrate that the use of APL is growing in an epidemic fashion. The authors are using 3 papers pretty much to create this paper. I have provided the links to the DOIs of the 3 papers, should you be interested in to look into them as well. And the theory of epidemic processes is applied in an approximate manner by means of data provided by nearly exhaustive bibliography given as an appendix. So it's the 340 papers we just saw. And APL, the authors claim that it's proved to be undoubtedly epidemic. I would say here as a remark, well, they say later also that's an approximation, approximate manner. And so it's not, a definite proof. It's something that you can maybe conclude from the data, comparing with the graphs that will show, we'll see as follows. So the introduction on the paper, from the paper. Okay. They said that so the past years there were some conferences, and they had demonstrated that the use of APL had a fast growth. And so in this conference, they would like to show that APL is still active and pervading it's pervading every area of activity. And I really like this paper because they use somewhat sarcastic language, maybe. So they talked about the vilifiers of APL, and we can remember some pretty famous people like Dijkstra, who was, he didn't like APL that much. And here the authors say that this pattern of development resembles the spread of infectious disease. And then they say that the purpose of this paper is twofold: establishing that the APL is an epidemic, and which is a common assertion among the APL supporters and practitioners, and then provide the APL community and the APL addicts, and I use the typo here, an extended bibliography which they give in the appendix. So they say, to their knowledge, such a bibliography has not been made available so far before this paper. And here they start, this is the juicy part, the epidemiology of APL. And they say that the spread of scientific ideas has already been studied in terms of epidemic process. So these are the three papers they are using to base this research. And a thorough theory has been laid down and applied to the study of an entire discipline, such as symbolic logic, for 100-year time interval. So I will fix the markdown. I'll put the hyperlinks here properly, so you can click and go to the reference below. And here they have given these two plots. They attempt to apply the theory. So the third paper, let's go a bit below, is this one of Goffman. And he did a paper on mathematical method for analyzing the growth of a scientific discipline, which I think it's very interesting. Unfortunately, I didn't have the time to go through these three papers. I will, and maybe I can do an extra video on those inside the meetup or outside the meetup. I haven't decided yet. So then they say, yes, they apply pretty much the theory of the paper 3 on the growth of APL as a scientific discipline, much. And they use a database of a bibliography recently compiled. So they have these two figures here, and we see here on the x-axis the year, so 1 year steps, and the y-axis is the number of new contributors. And we see that there's the curve is rising, so from 61 until close to 71. Where's the last data, and they're trying to extrapolate and assume that it will continue growing. And then on the figure 2, they have the change. So I think the change is like the rate, so some kind of the derivative of the active contributors, the number of active contributors per time, I would say. That's how I understand it. So it seems that the change, so let's say the acceleration pretty much, in the rate, how much the change rises per year, we see that it grows from 68 to 71. Well, it doesn't look linear exactly, but I wouldn't say that's exponential as well. I don't know. They claim, as we see later, that it looks exponential. Maybe it is. We can discuss this afterwards if you want. And then I have put the same image. Sorry. So let me fix that. So I think this is the second one, and I will add it later. No. Yeah, this one. Sorry, this one is the second one. Yes, so they showed this was the second graph with figures 3 and figures 4. And they have here a distribution of publications in 1 year intervals. We remember that the first graph here had the number of contributors with the change of the active contributors. And now here they have the publications per year and the ratio of publications to authors. So yeah, I don't really get this graph, how it helps to prove their argument that it's epidemic. So it's the number of publications per number of authors. That's how I understand. So 61, it raises from 1 to 2, and then it starts slowly falls and stays between 1 and 2. Then they explain a bit more those graphs, and they say that the literature's research is not exhaustive and improvements can be made. And then they try to draw the parallels between the epidemiology research and what they did. And they say that it's 330 entries of the bibliography they selected with 220 authors. So if we assume that APL is an epidemic process, we are talking about 220 individuals, a population of 220 individuals or infections over a 10-year span. So they're assuming that APL is a disease that gets spread between 220 people. And then they say that an entry may include several authors. The total number of applications is more than 330. So they say that's here they measure pretty much the total publications of all those individuals, even if they are in the same paper. And then they explain each figure. So figure 1 shows the number of new contributions each year. Figure 2 showing the change in the number of active contributions and represents the epidemic curve. This curve, they say, reveals clearly that since 1968, APL is really an epidemic. So if we go again a bit up, so 1968, they claim that since here, so from here, it starts rising, the change starts accelerating pretty much. And then they say that in 1968, infectious material, as they jokingly, I suppose, call it, by IBM, or APL 360, which, as you might know, it was a major milestone in APL's spread in the world of computing. It was pretty much released then in 1968. And then the shape, they say, of this epidemic curve does not allow one to foresee that the epidemic will stabilize. And they say, according to theory, this should occur when the curve ceases to increase. So in fact, this curve tends to grow exponentially. Forgive my typos, I'll fix them later. So it looks, yes, I wouldn't say it's linear. It looks like it's growing pretty fast, but maybe we could, plot later the data and do an exponential curve fit and see how exponential it is. And then they speak about the figure 3. So this is figure 3 and figure 4. And it gives, they say, the yearly number of publications. If the present rate of growth is maintained this year, we may expect 250 papers in 1972 with 40 new authors. So 40 new people that will be infected by the APL virus. Figure 4 indicates the yearly average number of publications per author. And the registration has increased continuously since 1969. So 1969 is here, and we see that there's been a small increase. But yeah, it's been increased, a bit decreased from 68 to 69, and then it was increasing from 69 to 71. Now, yes, well, history, I assume that shows that this curve didn't continue rising. This is one of the questions I have later, why it didn't. We can, everyone can share their thoughts on that. And then they say the above figures should not be taken as accurate ones, but as mere benchmark manifesting that APL, in spite of its infectious character to certain people, is hale and hearty and thriving at a pace which may endanger soon the bailiwicks. So bailiwicks is which I didn't know this word, so I looked it up. It's bailiwick. Yeah, okay. Bailiwick. Bailiwick. Oh. Bailiwicks. Okay, I can look it up later. So it's I remember the term means those that protect the area that they care about. So they talk about those die-hard fossils like dinosaurs that Fortran, Basic, and other people are. So yes, they pretty much they said that it might even infect people that are using Fortran and Basic, which were very strong at that time, 1972. Well, we know Fortran is from the 50s and Basic a bit after that. And so after they said about the bibliography, and they say that's sufficient to be convinced that APL is present in many fields, and that they tend to make general comments for the use of this bibliography. And then they had listed some implementations of APL. I didn't know any of the others pretty much, to be honest. I just knew the IBM implementations. And so the numbers correspond to the papers they reference in the appendix. So they say that APL is found in major computers besides IBM, and they mention all these manufacturers of computers. Univac is the one I know from the other ones, and IBM, but the other ones no. And then they speak about the APL compatible terminals, peripherals, and they have a reference of the 177 paper and more references to the other papers. And then something about APL data handling. They say that the users of APL have demanded facilities to work with large collection of data, and the number of file systems have been experimented or are presently available, and they share the papers there. And then they share the handbooks, some handbooks or user manuals, videotapes, other media they had at the time. So we see so APL as batch processing, data acquisition, graphics, history, implementation, plotting, semantics, theory. And then there are the conclusions. Okay, and then they share actually this significant fields. So the conclusions are, so besides the aspect of the paper, aim to, pretty much to throw some arrows to the people that abandon APL. They hope it will be a contribution to the spreading of APL. And they propose that this bibliography to be augmented, improved, refined, and possibly with the help of KWIC index, which is a keyword in context. It's a bibliographic term. I didn't know that either. So it's a common format for contornous lines. And this is a system that was proposed by some guy, 1864. And I think it's how to create indexes, actually, from what I understand. And then in the following, they gave some fields of application and the corresponding papers from the research. So commercial, computer-aided instruction, databases, engineering, finance, insurance, management, mathematics. We see there's a lot of things there, which is nice. Medicine, recreation, and games, and taxes. So here are the three papers that they reference. I think so. In the first one, I don't think you can. Maybe you can download it for free from ACM. Oh no, it's in Nature. So I can look it up and maybe share it with you later. And the second one is, I think it's in a, you can get it from the JSTOR. If you create a free account, you can read it for free. So it offers you 100 articles per month for free. And then the third paper, I think it's free. It's on ACM, but it's, I think it's free because it's related to APL. I think they did something like that. So yes, you can see here, if you press the PDF, you can read it from there. Okay. So this was the paper. It was very short, and I didn't do as much as I would like to. I had some ideas I could try to reproduce, so I have put them in the future work. So we can discuss now if you want. I have some questions typed, and if you have other questions as well, we can discuss them. And so the questions I wrote were, why do you think that APL has stopped being an epidemic? As the article claims, that used to be from 60s, 68 to 72. And if APL was an epidemic in the 70s, yes, what do you think? How was the cure? And pretty much stopped it from being an epidemic. The other question is, which programming languages today you think they could be thought as to be spreading as fast as an epidemic in the programmers communities, the IT world, and all that. So feel free to unmute yourself if you want to share your thoughts. It would be great, because this is pretty much the reason I'm doing this kind of meetups with the papers, so we can discuss live.
I'll try.
Hi. Yeah, sure. Hi. Thank you. Welcome.
Thank you very much. So I have an idea. I think that APL stopped being an epidemic because there were other languages that were easier for people to take on, right? Anybody who's been doing this a long time, I'm not pretending to, will know that things that are technically superior, which is what I feel APL and J and the array programming languages are, often, they don't take the first time, right? We have the history of Unix that teaches us something about this kind of pattern. And now all of our servers are on Linux, right? Or something that's Unix-like. And so I think the same thing is what's happening here with APL and the array programming languages. I think if it weren't for those third and fourth generation languages that, this kind of thing couldn't achieve a critical mass, right? And so we had to get to the point where,
yes,
and I'll stop talking here in a minute. I think we had to get to the point where programming and the people who do it weren't seen as some sort of dark art, some sort of mystical thing, right? It needed to be more accessible to more people. And if you think about the way that APL and J work, for instance,
back in the day,
coming back to this phrase of something that's called impedance mismatch, right? How it is that you translate what is in your problem domain into something that you can express in APL and J is almost mysterious. I mean, you really have to have achieved a certain kind of thing. Whereas if you get to COBOL, it's almost like English. Do you know what I mean?
Yes. And Fortran also is very easy to go from the mathematical form to code.
Yeah. And I think these kinds of things are periodic, right? And I think the pendulum is swinging back in the opposite direction. I think that there's so much spore with regular sort of English-like programming languages that you are missing what the thread is of the computation in data, right? And so I think that there's a new crop. I want to be one of them, right? I think there's a new crop of people who are saying, wait a minute, we missed something.
Yes.
There's value in learning how to think of things this way. And so I think the task before us now is to get more people thinking like this.
Yes. That's a very nice insight. Thank you, Amilcar, if I say your name correctly.
Yeah.
So yes, I'm thinking. Thanks. I'm thinking that I noticed that I think at least maybe because APL and J are, I think they're array programming languages, but I think they're closely related to functional languages as well. Kind of. So I see a trend now, functional languages becoming more popular. So maybe APL and J will ride that wave along with functional languages. And yes, as you said, it took a lot of time for Unix and Linux systems to be mainstream for servers and now in the cloud. I guess it takes time for some ideas to reach more people.
Indeed, indeed. What I would say, if I could add just a little bit to that.
Sure, of course.
Is that I found these languages because I like languages. I like to learn them, right? Including human languages. And I'd spend enough time with Haskell as an example of a functional programming language that's supposed to be pure, etc.
Yes.
I even spent time with Michael Liarmakopoulos at a couple of conferences. And I think why I prefer these is because they're not so verbose. In my life, my friends, I'm so talkative.
No, please. Well, it's this meetup really is about discussion and exchanging ideas. So I appreciate that you have, the courage.
Yeah. As a person, I'm so sort of chatty and so talkative that I find that I want something that is much more concise when I'm programming. If I'm going to spend an afternoon on a Saturday or the evening on a Sunday doing something, I want to be able to express myself with a minimum, and I find that I'm able to do that with APL and with J.
Yes, it's very compact, and you can pretty much compress the computations in short number of characters.
Indeed, and it feels like what programming was supposed to be, right? So after you learn the vocabulary of the symbols that are at issue here, including the J digraphs,
yes,
right?
Yes,
it's really about sort of composing the computation after that. That's very much functional, right?
Yes, exactly. Yes.
Whereas, I could see, if I looked into a code base that were written in, say, C# or Java or something much more conventional, I don't know. I get tired even thinking about it because the pattern isn't there, right? You have to learn how it is that the programmer who originally programmed it, if it wasn't you, thought about the problem domain, and sometimes you do wonder whether or not they have enough of vocabulary to be able to express themselves well. Whereas with APL, you look at anybody's APL code or you look at anybody's J code, and the symbols mean what they mean. Right? And so by acquainting yourselves with the data, you kind of figure out pretty quickly what's happening.
Yes, I took part of the recent functional conf. It was amazing, actually. If you haven't been, you should next year. I'm planning. And Aaron Shu from Dialogue spoke there about his work, and we had discussion afterwards about if he was talking about I think how it was a serial approach of programming. So you create blocks of computation that are linked pretty much like in chain, and this really very much reminded me of pipes in Unix. And I asked him if he thinks it's a parallel, if it's very like the same thing, and he agreed that it's like you pipe functions or verbs, and you pretty much stream the computation and the data from in a data flow pretty much, because he was I think yes he was speaking of a serial data flow. So you have, when you write your code in APL or J, from top to bottom, the data flows from top to bottom, and it's pretty amazing because you can break the computations in blocks, and it's like Lego in the end. So it's great. Yes.
So if I could, pardon me,
sure.
I'm going to try to say your name. I have one of those names.
Oh,
right?
okay.
It's Portuguese, but your first name is Michail?
Yes, it's very close. So it depends where you are. In Spain, Spanish people pronounce it in Spanish Michail, but Michail, it's not correct that much. in Greek, because I'm Greek, it's Michail. It's more soft. But Michail, which is Michail or Michael in English, it's fine.
Okay.
Or even Mike. I go with Mike too.
Okay, I'm going to try, because there are really only 7 letters in my name, and I like for people to try. Michail.
Oh, yeah, sounds great. Thanks.
Great. So if I can try the second part of the first question, right?
Yes.
If APL was an epidemic in the 70s, what do you think was the cure? I don't think there was, I think the question was meant rhetorically and a little bit tongue in cheek, but I don't think there was a cure. I think we're finding APL, NJ, etc., BQN, etc., are their own cure to something that has blighted us for a little while.
Yes, maybe the word cure wasn't the best I could have picked.
It's all good. I have met a few people who make programming languages in their spare time.
Yes, this is amazing. Actually, I've met some in the Discord of APL JK. Some people.
Exactly.
And, yeah. So there, I'm very, I'm not that level of programming, and I'm really amazed by those people that create their own languages.
I have the Dragon book, and I gather it's worth a lot of money now, so I think I'll hold on to it.
Yes, I think it's a very historical book, so you should keep it. Yeah.
But these people will tell me about how they feel like a lot of the software that the world is running on is bloated. They came up during a time where they had to be very, very careful about how much memory they used, etc.
Yes.
And so if I can adapt the sort of Unix analogy to Linux today, what I would say is that I think our software is bloated as well. And so the reason I would say that APL, and I bet this is probably something that Aaron Chu would say as well, right? I think APL and J are the cure for the detour that we've been on with sort of English-like programming languages and things that take a lot of time to be able to express the algorithm and time to be able to execute the algorithm, because something that should be embarrassingly parallel, sort of image manipulation or something, you're really doing in serial chunks, to your point. Whereas if you had been able to express it the way that you'd intended in a language like APL or J or something else, you had the opportunity to recover that parallelism that you lost, translating it into something that just wasn't capable.
So it's pretty much the curse of the von Neumann architecture, right?
Yeah, that's right.
Down that road, and yeah, we've been down that road since the 40s, and
And then last, just because you had these brilliant questions, and it really did get me thinking.
Thank you.
Which programming languages today do you think could be thought of as spreading as fast as an epidemic? Oh, I have some ideas. There's one
question, actually.
I know. I think probably JavaScript, right? I think
it's everywhere indeed.
It's everywhere. I'll be honest with you. I've programmed in JavaScript myself because, like I said, I like to collect languages, and I'll
sure. I'm not judging.
It's okay.
I don't like it. I haven't.
I don't like it.
I don't like it. I haven't actually. I haven't got the need to learn it, so I don't really know much about it. But
well, I did
don't know.
Yeah. I did it for front-end programming, and I feel exactly the same way you do. I don't like it. And I think probably one of the reasons that it's spreading is because of the cloud. It's the way that you program
and the web,
cloud.
the web, pretty much.
And the web. Well, it was always in the web, right? But if you're a young person, I'm not so young, right? But if you're a young person and you're wanting to make a living, a career now in this space, you want to talk about AWS and Azure and GCP. You're not interested in the small stuff. Yeah. And so what they have to offer you is Python or JavaScript or something else. I don't begrudge them that at all. But I think that is a selection pressure on JavaScript that's helping it to spread probably beyond where it would otherwise be, right? And I'm not sure it's
well, regarding data-oriented tasks and jobs, I think Python is more fast spreading than JavaScript.
That's true.
Well, I'm not sure if it's still spreading, because I think it's already everywhere now. It has, dominated the field the last, 10, 15 years maybe.
I agree.
And I'm not sure about. I would like to do in the future work. I have put some bullets there. I'm very curious how fast Julia is spreading, for example, because it's very, in my opinion, a very strong successor, I would say, or someone that maybe steal the crown from Python in the future. I don't know, maybe.
I think you're onto something, because Julia is one of the ones that I've been keeping up with probably the last 2 years or so, just because of sort of compiler intrinsics and SIMD computation that's supposed to be native once you're able to express yourself in Julia.
Yes.
Look, I'm gonna be honest with you. I love Python. I love how open,
of course.
it is.
Me too.
Anything that I have an interest in, I can open up the source, right? But I do think that Julia is coming on strong. What I don't see is where Julia's not taking over the world as quickly as I thought it would, and I don't know why.
Yeah,
maybe new, and I don't know why.
Yeah, I don't know why. I've heard that before. That I don't know from whom, but that that they say that Julia will become the next Python. They've been saying that for I don't know in the last 5-10 years, and it still hasn't. So, well, I don't think Python is going anywhere. But on the other hand, Julia is based on some libraries of Python, so it's built up. It's taking something from there. But I like, I think Python was like the first serious language I learned after Basic and Fortran. For we did Fortran in the uni and Basic before uni. And I'm a bit tired that it's dynamic typed. I use everywhere type hints, and if I want something to speed up, I use Python. I write some modules in Python and compile them, whereas Julia is strongly typed. It compiles. So it looks like it has all the things that Python could have been. It's like that. So, and also I found some very interesting libraries in Julia already written. I'm very interested in interval analysis, which is like a numerics. That's not very popular, and there's an excellent library in Julia from some professors in Mexico, and many libraries, actually very interesting libraries.
Very good. Yeah, I'm interested in Julia. I'm interested in the library in Julia that does Monte Carlo simulations.
Oh, nice.
Stan, right? And it's really easy to use Stan inside of Julia, which is I think one of the things that sort of hooked me right away. I think to your point, Michail, is that I think the reason, if you forced me to say, I think the reason why Julia isn't taking off is because Python is already everywhere.
Yeah.
And it has much more inertia than
exactly. Yes.
Analogy, right?
It's established. So why should someone now learn Julia instead of Python? They will learn Python, of course.
I feel the answer to that question is the global interpreter lock, but clearly it's not jamming enough people that they would abandon probably years of knowledge and learning and code, legacy code on Python to go to something that's new just because it's new.
Yes, that's true. That's true. And from the functional languages, which one do you think it's catching up steam?
Well, this was. Yeah, please, you first.
Yeah, I'm thinking. I haven't decided yet, but I got some interest lately in Erlang and Elixir because I did some Prolog in the uni, and Erlang looks so much close to Prolog. The syntax, well, it's functional, it's logical, but the syntax is very inspired from Prolog, and I really like that it's very scalable and reliable and all that. And Elixir comes from Erlang, and it's like with Ruby all together. So I those two languages are very interesting. And in the JVM, well, yeah, if I want to go into a typed language, I think I would go in Scala, which I'm trying to learn right now, because I want to get into Spark actually. So I know you can do PySpark, but I think it's a bit limited if instead of using Scala with Spark.
Yeah.
And just a final point, the JVM, if you go to dynamic, closure. I think if you've done some scheme or some Lisp a bit, closure, I think
I've done scheme. I've done scheme.
I'm reading. I don't have it here. I just bought the little skimmer and I'm going.
Yeah, that's right. I'm sorry. I'm excited. Right. I did this. I did the same thing a little while ago. For me, I'll be honest. For me, for functional programs, it's always been Haskell. Right. I came to Haskell. Oh, Michail, it's a long time ago. maybe 2000 when I read that first Simon Thompson book.
Mm-hmm.
And I thought to myself, okay, this is it. There's something here, right?
Yeah, that's true. That's true.
And again, I've been with it for a little while. And at one point, like I said, Michael Snoyman, he and I had a conversation. I don't even know if he remembers it, at Fantasyland Institute in Boulder, Colorado, back in 2017, I think. And I remember saying to him, I love Haskell. I would love to get this off the ground where I work, but there's not enough support. I really would be sticking my head out there saying that we should try to find this kind of talent in the marketplace and bring it in and have them develop libraries that, if it was difficult to find people in the marketplace, well, that problem has resolved since then. But I think the issue for me with Haskell is it's still kind of esoteric, and for my taste, it's still a little too verbose, I think.
How do you mean that?
Well, when I think about how it is that I would approach a problem, I don't know if you're familiar with something called Turtle, which is a way of using Haskell, basically to script your operating system, right?
I'll look it up. I didn't know that. No.
Turtle's an interpreter that basically allows you to write shell scripts in Haskell, right?
Oh, okay.
So, if I'm going to do this, right, considering that I use NixOS, for instance, as my distribution of choice, right? And Nix language is very close to Haskell.
This is NixOS, by the way. Since you mentioned it, I recently encountered it because I don't remember. There was a library or tool that I can remember. So it was I think some tool I want to install on my Linux, and it had you should have it was built for Nix. But then it had some advice, if you want to install it in Linux, you should do something else. So then I, learned about NixOS, and I was like, well, what's that? Okay. So is it like related to Haskell, the NixOS, or?
It's inspired by Haskell. It's not close enough to Haskell for people who know Haskell to feel comfortable being in the Nix language all the time. Okay. But it's also simpler, right? And so a lot of those Nix packages and those Nix flakes are done in this Nix programming language, right? If you're familiar with Haskell syntax, it's easy for you to see what's happening, right? And so that makes it not so daunting, if that makes sense. Haskell, I like I said, I think it was becoming a little too verbose for me. I couldn't find the talent. A lot of what I saw in the Haskell literature was about monads and academic
category theory.
Exactly, category theory. You could go very deep on that stuff and sort of displace the goal, right? I say, look, I need to do analysis. I need to do business intelligence. I need to do econometric analysis. I think Haskell would be it, but finding that talent's very rare. It's still very rare.
Yes, if you put on top of your domain knowledge fields some theoretical like category theory or abstract algebra, it can be a bit of a pain.
Indeed. And those people have already been hired by State Street and the Wall Street firms, etc. So.
Oh yeah, like for quants and all that.
Exactly.
Yeah, they do hire math and physics PhDs, so that's true. But it's interesting. In this conference, there was an interesting talk I can share it later in a message, an email.
Please do.
In the group. Yes, very interesting talk by a very interesting gentleman from India that we've been in touch ever since. And I think he gave a talk with examples from Scala, but pretty much he was, saying that typed functional languages and their programs pretty much are applied abstract algebra, because you create like an algebra to model the properties of the problem you want to solve, and then you apply that algebra on the data or something like that, along those lines. So I was very intrigued by that.
Me too. Yeah.
So yeah, it was very clear. You had, I don't know, you had the identities. He was talking about commutative identities, the identity element, that doesn't change. So it was, just algebra, and it was very amazing to see. So deep and important mathematical concepts in programming. Haven't seen that before. So
indeed. Yeah, Haskell, pardon me, Haskell is where you spend your time thinking about those things. And if that's your bent, and I have it, just not all the time, right? Sometimes I just have to get things done, but if you have that, then Haskell is definitely the place to explore, domain-specific languages. It's definitely the place to explore even compiler optimizations, that kind of stuff.
It could be because I recently had an interview of John the Ghost, who's a very well-known person in Scala. You know that.
He was the one who did the Fantasyland Institute that I was talking to you about.
Oh, he did. I didn't know that. Okay.
That's where I met Michael Snyman. But yes.
All right. Yeah. So I think I heard an interview recently. He said that he went into. I think he was a C++ programmer, and then he went to Haskell, and then from Haskell he went to Scala. So it was interesting to see that many people go through Haskell, and maybe afterwards they go somewhere else. But most of the people now in functional programming seem that at some point they've been in Haskell.
It's true. And Haskell has things to teach us, right? Not just if you're interested in category theory or something else, right? And so the idea that, the core of your program should be functional and the imperative stuff should be at the edges. One of the reasons why APL and J speak to me is because you kind of have to do that. By the time you have to do something that isn't pure, you feel like you're in a completely different language, right?
Yeah.
And so in dialogue APL, for instance, if you're doing something impure, you're probably doing that sort of closed bracket and something that says, I'm at the edge of the language right now. And in J, those foreign function verbs are something else. Like, they're not easy to remember. I have to go back to the documentation every time. Right?
Yes, until they stick.
But when you're in the language and you're working in the grain of the language, everything is just so. I think it's one of the reasons why I think they're their own cure again.
You're right. So great discussion. I have some bullets in the future work, and I'm open for anyone who is interested into joining. So Tony wrote something in the chat. Rosetta Stone, NumPy book.
I want to do a -1
Tony, I've seen an article that they compare, they give some examples in NumPy and they give the equivalent in J. I can share that if you want. Just a second, I'll find it. It's a very interesting article. So NumPy versus J, I think it was like Iverson goes. Yeah, I think it's this one. So this could be something you'd find interesting, Tony. And so no, it's okay. Don't worry. It's fine. Thanks for asking questions in any way. We don't mind. So yes, I was really interested to see how we can do some similar analysis in, I don't know, the 10 most popular programming languages, using some array language to do the computations of that analysis and the plotting. So I'm thinking maybe I'll start some mini project on that if no one is interested. I would prefer in J because lately I've shifted towards J from APL. I don't know. I find it more with more ready-made libraries for analysis and data oriented calculations. I think the dialog APL is really amazing, and I really like the IDE, and they've done great work. But I think J is a bit more fine-tuned into such tasks.
Pardon me, I agree. My first array programming language was actually J.
Mm-hmm.
And so again, at that Fantasyland Institute that I went to probably 5 years ago now, Morten Kronberg was there with Aaron Schultz.
Oh, Morten, yeah, okay, with Aaron, okay.
And so he was doing a workshop, and that was my first introduction to APL.
Mm-hmm.
And I remember asking him in the room because I was having trouble getting everything to work on my laptop. And
yeah,
I was in the room and I said, well, I think one of the reasons why I like J is because, I was just beginning to learn it, and the idea of function inverses and obverses was something I thought, oh, I like this, right? And that you can do that pretty immediately if you do a tacit definition of a function was great. And so that's when Morten said, we actually have Roger Huey working for us, the late Roger Huey, right?
Yes, Roger. Yeah.
He didn't say that APL was going in that direction, but I felt better knowing that the name that I knew from J was actually working.
Yeah. I really like that Roger went to dialogue and worked, and he brought a lot of knowledge from J. So there's a nice connection between dialogue and J. It's really nice to see that. You don't see that very often in languages, I think.
Yeah, it's true. It's true.
And actually, J was my first array language back in 2015. But I found it, I thought it was interesting, and I saw that it had the server where you run it in the browser, and I thought it was very interesting. And then I saw the Jupyter notebooks after that. So I said the notebooks later, and now I think of it. Wow, J had notebooks before Python did. So it's very, very interesting. But yes, I couldn't appreciate back then. I thought, it's a bit esoteric, and I don't know what I'm doing with my life and that.
No. It's all good.
But now I find it very interesting and has value in the way you program and you think.
Yeah.
So yes, going through the future work bullets, if it's okay. I just post it to see if we can reach any similar conclusions for the 10 most popular languages of today, if they are still growing like an epidemic or not. And then I don't know, look for more languages, and maybe focus on the functional ones to see if they, what's their rate of their use and their growth. If we can measure that, it will be interesting. And the final, just try to reproduce the results of this paper, just using. It will take a bit. I don't know. I think just copy pasting the paper names and doing some simple data analytics. And then if you want, we can stretch it and more and look for some epidemic models to see how they compare with the results of the bibliometric analysis. So it was a funny and interesting small paper. I really liked it. The title actually drew me to this paper. I found it pretty amazing and quirky. So this was the meeting. I really thank you for joining and discussing, and it was amazing. If you have any other questions and you'd like to discuss, let me know, or you can even send me an email or chat through Discord. It would be great to see you there as well.
All right, great. Thank you very much, guys.
Sure. Thanks a lot, all of you, for joining and for listening to me and discussing all your questions and ideas. So see you soon, hopefully. Take care.
Take care.
Bye.
Bye-bye.
Stop sharing.